Hello everyone, welcome to this video. This is about the configuration of IPv4 addresses and static routes. So firstly, it's been a while since the last video, so I'm sorry there's been a delay there. But nevertheless, I'm back now and this should be a good lesson, so I'm really looking forward to it. So firstly, let's just get into what topics we're going to be covering. So there's network fundamentals, so the configuration, verification of IPv4, addressing of subnetting, IPv connectivity, so there's several aspects here. Things that we're going to be looking at, and then we're going to be looking at how routers make their forwarding decisions and configuring static routing. And there's different ways of doing this, achieving this. So we've got default routes, network routes, host routes, floating static routes. So this is directly from the exam topics. Now I'm going to try and simplify this. So 7 things we're going to be looking at. This lesson will be broken into 7 parts. Firstly, how routers route packets when the destination is local and non-local. So just looking at how those two things are different there. The IP address subnet, the IP address subcommand, and how we should use it and how not to use it. The proxy op. So you might have heard about op, but you might not know about what is proxy op. So we'll be looking at that. What is proxy op and what's it about? Static network routes and static default routes, static host routes, which I think of like a special route, troubleshooting static routes, and then finally floating static routes. So a lot of different variations of configuring routing here, but will be I'll be trying to make this simple for you guys, and should be a really good lesson. So I'm really excited. So let's get into it. So firstly, when it comes to routing locally and non-locally, it's just something very simple that we need to understand is if we're routing locally, this means we're doing it within a local area network, within a subnet. You've got 2 end devices. So for example, here you got PC1 and PC2 on. Now they are connected in the same subnet. The only thing that is separating them here is just switch 1. So there's the switch here. PC1 can send to that device through this switch within a subnet without having to go through something called a default gateway. As you probably know, the default gateway is that router which is connecting you to other subnets, and you need that default gateway to communicate across across your own subnet. But these hosts are within the same subnet, so we don't need that. We can just communicate directly, but we need something called ARP, Address Resolution Protocol, because that will take the IP. Because what will happen is PC1 will send a broadcast out to all the clients connected to switch 1. So let's say we had PC3, 4, 5, 6, 7, 8 can all attached to the switch, and it wants to find out it wants to know the MAC address of PC2. It sends a broadcast out saying, which is basically in basically human language. It's basically trying to say, it's basically like shouting, "Hey PC2, where are you, and what is your MAC address?" So it's looking for the IP address, is looking for the host that has the IP address. So rather than actually saying PC2, it's actually going to be shouting the IP address of PC2. So for example, you've got 192.168.0.5. So it'll be like 192.68.0.5, where are you? And that packet will then be sent across to all those hosts. So let's say we had PC2 here, but we had PC3 here, PC4 here, PC5 here, PC6 here, then PC7, then PC8 here. When PC2 gets that broadcast message, it will say, "That's me. And this is my MAC address," and it will send this MAC address back, and that will go to PC1, and then that is the ARP process there, in basically simply explained. So that's just great. That's what can happen within a subnet. Now, if we are routing non-locally, then we need the default gateway here. So for example, we've got this PC here, and it wants to communicate with a web server in Glasgow, Scotland. And so in this case, we are communicating with the host that is in a different subnet. It's connected, It's not so the issue here isn't it's not necessarily geographic. It's the fact that this web server has will have an IP address that's in a different subnet to this one. So there's a router that is needed, and so the PC will have to send this packet to the default gateway, the router, and then that router, because that has a route to the web server in Glasgow, it can send it to that subnet that's connected on, and then the packet is received by the web server eventually. So it's this very simple thing of routing on the same subnet. You don't need a default gateway. You can send without that, but you use ARP. And again here, we use ARP, but we are communicating with a different subnet. And so we need the default gateway. We need the default gateway here to route that packet. Now let's look into how routers are actually adding their routes into IP routing tables. So there's three methods that we need to know about. So connected routes, okay, and those are routes for subnets that attach to the router interface, and we add them using the IP address interface subcommand. Connected routes, okay, so routers for subnets that attach to a router interface. Static routes are the routes that are manually configured into a routing table, and they are added using the IP route global command. And then finally, routing protocols. So we've got connected routes, static routes, and routing protocols. So let's look at the IP address interface subcommand. So we use this to configure those connected routes, but we need to take care when we configure that we don't use a reserved IP address. A reserved IP address is, for example, if you remember from our subnet videos, when we're working out subnetting, we need to work out what the subnet IDs and the broadcast addresses, because we don't route to those. We don't use them for hosts. We don't configure them for hosts. Those are reserved, and so likewise, we can't use them here in the configuration of the IP address subcommand. We can't use them, so we have to leave them alone. And if we otherwise, things aren't going to work out. We can't use subnet ID. We can't use the broadcast address. Now, also, we must not, and I emphasize it, must not configure more than one IP address per subnet, because when you configure the second IP address in the same subnet, it will be rejected. It will be rejected. So the second IP address in the same subnet will be rejected. We don't want that. So it's something also to keep in mind here. Now let's get into proxy ARP. And proxy ARP is something that is quite clever. So a proxy ARP is basically when a router is responding to an ARP request that is intended for another host. Don't worry, I'll give you an example. But a router is like we've got here. So basically, so I just want to point. I'm just trying to point to this. Right, forgive me. I can't get my pointer to actually come on the display and show you. But if you look at that router is router 1. And here you've got, beneath you got two hosts. So you got 10.1.1/24 and 10.1.1.2/8. On the other side of R1, you got that server 1, 10.2.2.100/24 S1, server 1. So what is proxy ARP helping us with here? Well, basically, that host on the bottom right-hand side, 10.1.1.2/8, that's in a different subnet to the host on the left. And so this host, because it's actually, and the reason why it's got a different subnet mask is because it's been configured incorrectly. It's not being configured with the correct subnet mask, and then therefore it thinks that that server on the other side, it's in the same subnet. Of course, it's wrong, but because of this incorrect subnet mask, it's kind of in a delusion, thinking that that server is in the same subnet. And so this is a problem. It's a problem. If this host wants to send packets to that server, it's a problem because it thinks in the same subnet, even though it's not. It's confused. It's confused because of that incorrect subnet mask. But proxy ARP is something that's clever because and can really useful because proxy ARP, when when that when the router receives the packet from that host on that deluded host on the right hand side, bottom right hand side, it will it will basically make that PC believe that the router is server one, and this is something that's not malicious. It's trying to solve a problem here. So it will make the PC believe that 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 the router itself is the server, and this enables that communication. Otherwise, you couldn't have communication between that server and that router. That host. Because of that misconfiguration there. So what's happening is that router is responding to the ARP request that's intended for another host, and proxy ARP is helping the host in a subnet reach other hosts in a remote subnet without the need for configuring route or reaching a default. Okay, it's really cool when you think about it that this can even be possible. The way it actually helps solve this problem, because this can happen. It can happen. Mistakes by just manual errors sometimes. But proxy op is defined in RFC 1027. It's important to know about, not just for this situation, but there's another use case for this as well. So proxy op is needed when you configure a static route using an outgoing interface rather than an IP address as well. It's something also very important to remember. If you configure a static route using an outgoing interface, for example, gigabit Ethernet 0/0/0 rather than IP address, that is also required there. But back to this example, proxy op is, here's better now, I can actually point, but yeah, this host had the incorrect subnet mask, and therefore it believes that this server is in the same subnet, because it believes that any IP address from this range 10.0.0.1 to 10.255.255.254 is all in this local subnet. It thinks they're all in that same subnet. That's wrong. So that's a problem. But host B and host B's broadcast messages aren't going to go beyond this router. However, that router will respond to host B's ARP request, and host B will think that the response is from S1. It's not a bad thing. It's not a malicious thing. It's actually solving up really a big problem here, and it enables that communication to happen. So host B will keep throwing broadcast messages out. Otherwise, if route 1 doesn't respond to that ARP request, and host B can keep throwing broadcasts at the router, and they're just gonna and nothing's gonna happen. Okay, it's like you're trying to it's like you're trying to bang on a door and it's not opening. Until that or the person on the side opens the door. Like if you go to your friend's house, though, you can bang on the door as much as you want. Okay, one, you're gonna look like a fool because it's all caught on their Ring doorbell. But the point is, if you keep banging on the door, they're not gonna open up until the person on the side will open the door for you, will answer. And similarly here, because of this misconfigured subnet mask, host B keep banging on the door. Route 1 doesn't respond. There's no communication. But because Route 1 responds to that ARP request, Route 1 will kind of be like, okay, I'm S1, so you can send everything to me, and Route 1 makes everything work. So proxy op is really, really cool. But remember, proxy op is something that we'd also use if we if we configure a static route using an outgoing ER interface, like gigabit Ethernet 0/0/0 rather than IP addresses. Proxy op is also needed in that circumstance as well. There was a good website that I was reading about proxy op on, and I'll share that in the description of this video so you can check it out afterwards. So that really helped me when I was learning about this. So some important commands. So you can use show IP ARP to view an ARP table. Now you might also want to empty a single IP address or all dynamic entries, and you using the clear IP ARP, then insert the IP address command. So this is an exec command that you can use. Clear IP ARP, and then insert the IP address. Okay. Show IP ARP will give you that ARP table. Clear IP ARP, insert the IP address lets you empty a single IP address, all dynamic entries. So another important thing is, by default, all your ARP entries will time out if they're not used after 240 minutes in subscribers. So that's 4 hours. After 4 hours of non-use, and ARP entries are removed. Okay, sorry, they time out. They time out. So after 4 hours, 240 minutes of non-use. So, and yeah, very important point. Cisco route will automatically add a route to its routing table for each interface if these two conditions are met. So the interface needs to be in an up state, and the interface has an IP address configured through the IP address interface subcommand. So the interface needs to be in a working up state, and the IP address needs to be configured through the IP interface. Sorry, excuse me, the IP address interface subcommand. Two conditions, very important conditions. If the interface is up, that route's not going to go in the routing table. If you're not configured the correct IP and a correct IP address, valid IP address, then also the route won't be added to the routing table. So these are very important things for us to know when it comes to troubleshooting. So we need static routes for all subnets for both directions of packet flow. Configuring static routes using next hop IP address and outgoing interface both work, but using the next, remember we need proxy op here though, but if we use the next hop IP address, that's better, it causes less confusion. And yes, using the outgoing interface on an Ethernet link requires the use of proxy op. So, static network routes and static default routes. Now, something very important that we do not get confused between these two terms. A default route is a special route that's used as a last resort when there's no specific route matching a packet in the routing table. No specific route matching a packet in the routing table, we use the default route. And a network route is a route that matches addresses in a specific in a specific entire IP address, or a specific entire IP address range, or subnet. So the default route is basically that's used as it's basically last resort. You got no route that's matching that packet that you have. So for example, you got host one and he wants to send this packet. It can't, right? So, router one it's got a packet it needs to send to router two, but it's got no route that matters. That precisely matches the route in the routing table, but it's got this route, the default route, and so when failing the process of finding an appropriate IP address in its match in the routing table, failing the if it doesn't find the match, that process fails. It can send out using this. So it's like you can't do. It's like if you think about it in a flowchart sense. You know, if you find a match, send using that matching IP address. But if you can't find it, that's fine. You can use the default route. So it gives that peace of mind that hey, if you can't find a match, don't worry about it. Use the default route. That's the purpose of the default route. The network route, that's a route that's matching addresses in a specific entire IP address range or a subnet. So let's go into now static host routes. So these are what I think of special routes, and I'll explain why. So the static host route is basically used for a single host address, just a one host address. Okay, excuse me. So we use a subnet mask. Sorry, that is that's supposed to be 255.255.255.255 there. So that will only match one address. So sorry about that. That's ignore that zero. That's actually 4 255s there. 255.255.255.255. That is the subnet mask. Okay. So the use case is quite rare for this. It would be rare that you'd actually need to use this in real life, but it's important to know for this exam. So but we're only using here for a single host address. So for example, here we've got 4 routers, right? Now these are all 4 routers in New York City. Okay, so New York City router 1, router 2, router 3, router 4. What's happening here is here you've got PC 114 config. Okay, that's connected to router 4. Now, this is one specific host. Okay, this is IP address 172.16.10.10. Now that's one specific host attached to router 4, and what's happening is this PC, what we've got here with this static, we've got static host route configured on this router. which is basically telling router 1 that if you've got a packet that's destined for PC 114, that you just to use this route here, go via router 2 and then router 4. Use that route. Otherwise, for anything else for this subnet 172.16.10.0/26, send it via this route. So this is the route that's normally going to be taken, but only for specific, the very specific case where you're sending to PC 114, you'd actually go and take this route via router 2 and router 4. Otherwise, use router 3 and then go to router 4. So that's basically static host routes there. Okay, it's used if you to create like, it's almost like basically like here you've got an exception, but it's a very specific rule for one host address. When you're configuring a route for one specific host address, you can use a static host route. Again, the use case of this is quite rare, but it's important to know about it for the exam. So hence why it's in this lesson. Now, let's talk about floating static routes. So a floating static route basically acts as a backup. It's a backup. So in case your primary route fails, like here, what we've got here, we've got two routers in San Francisco. San Francisco router 1 and San Francisco router 2. Okay, SF router 1, SF router 2. Now the primary link is here. This is an EIGRP route. Okay, so this gigabit Ethernet 000 interface connected to this gigabit Ethernet 002 interface, right? So we're taking this route. However, if that route fails, we are going to use this floating static route, which is a cellular route. Okay, we're using cellular communications here. So cellular interface 010 to cellular 010 interface on router 2. So this primary connection goes down. We use the backup route. Okay. The floating static route, which effectively acts as a backup route. What we need to remember though is we need to assign a lower administrative distance for this floating static route, because this is supposed to be the backup. Otherwise, by default, this will become that primary route. We don't want to be using that because that's not intended for that. And cellular communication, as great as it is, compared to now, of course, it depends on your standards of the link that's being used, but generally, if you've got, we want to use this. We want to use this route. We want to use this route. Okay, that's using Ethernet. We don't want to use this route. So, but that cellular. So what we need to do is assign a low administrative distance, because that administrative distance is like a trust value. It's like a trust score. How much do we trust that route? The lower the better, not the higher the better. The lower the better. The lower the better. So the lower, the more trustworthy that route becomes. So we want to assign a lower administrative distance. A higher administrative distance actually, a higher administrative distance for this floating static route, so it doesn't become the primary route by itself. So we want to downscore it. And so, but actually, effectively, what we're doing, because the low administrative distance is better, we need to give this a higher, higher administrative distance for that floating static route. Sorry for the confusion there, by the way. That's a high administrative distance we need to give. Now, finally, troubleshooting static routes. So this is number 7, the last part. There are 3 issues, at least 3 issues that can occur when troubleshooting static routes. So one is that routing table is in the routing table. That route is in the routing table is incorrect, meaning someone tried to configure a route. The syntax was valid. The way you configured it was fine. So iOS will accept it. However, it was actually correct. It wasn't the correct IP address that you need to configure. For example, you need to configure 117.16.2.2, for example. Instead, you made a mistake and you by accident did 172.16.2.2. So you added an extra 2 in. That's the incorrect IP address. iOS will accept the command, but that's not right. It's like someone wants to purchase a bus ticket, and their bus is supposed to go. They want the 9 a.m. ticket, and by accident they book the 10 a.m. ticket. Now the bus company will accept the order because it's a valid time. However, it wasn't the right time for the customer. It wasn't the right time. They needed the 9 a.m. bus to be able to get to a meeting on time. Let's say they had to go to a job interview. They need to get that job interview on time. 10 a.m. is too late. It's the wrong time for them. But in terms of how the process of them booking it, it was all valid. So the bus company accepted the purchase. So similarly, if you can misconfigure a route but use the valid syntax, iOS will accept it, but it's not the right IP address for you. So it's not useful to you in that sense. That's not helpful to you. So this is one issue that can config when you configure static routes. Another issue is that the route is not in the routing table at all. Okay, and that might be because the interfaces weren't in an op state. Someone might have configured, might be working at a service provider, for example. They wanted to configure a router for a circuit that hasn't gone live yet. Now, because that circuit hasn't gone live yet, that route can't be configured in that. But let me give you another example. But basically, if you configure a route for, if you want to configure a route, and your interfaces aren't in an op state. For example, you are logged into a router. Let's say you consoled into a router. You didn't realize that the interface wasn't in an op state, but you tried configuring a route in the router table, and it doesn't get configured. You can't configure it. You're trouble issues. Then when you dig deeper, you find out, oh wait, the interface is down, and because the interface is down, you can't configure the route. However, you can do something which is add permanent after your configuration. After that configuration of your IP address, you can add this word permanent, and that would still put the route in the routing table, even though that the interfaces aren't in an op state. So there's a way to get around this, but this is very important to note that the route, if it's not in the routing table, and there's one reason why, because the interfaces are in an op state. If the route is not in the routing table, that's an issue there. But that's one reason behind it. And let's look at the last thing. So the route is in the routing table. It's correct. However, the packets do not arrive at the destination host. And there can be multiple reasons for this. So these are some issues that can occur when troubleshooting static routes. Something I'm thinking about is maybe getting another video, a shorter video out, just to explain these issues even in more detail and give you some examples. But that brings me to this video. So thank you so much, guys, for watching. Really, really appreciate it, as always. And please like, share, and subscribe. And I'll see you in the next video. Thank you so much for watching. Thank you. Goodbye.